right. Well, good morning, good afternoon, everyone. Welcome to today's Exploring by the Seat of Your Pants event. My name is Joe Gorowski, and I'll be your host for today. We are coming up really, really fast on the end of November. I can't believe how fast this month has gone. It has been one crazy event month. So much live content we threw your way. We started the month with our CNN Call to Earth Week, where we hosted scientists, explorers, conservationists from all over the world who are on the front lines of our changing planet and bringing these really important stories back to us, as well as with solutions. So if you do want to catch some of those past events, you can head to our website. Under our events, you will find that Call to Earth Week. And then the last 3 weeks of November, we focused on a new theme. We've always had archaeologists and paleontologists, geologists join us, but we've never turned a month into a themed event. So we called it Can You Dig It? And we had archaeologists, paleontologists, geologists from around the world join us to share the really cool work that they're doing. So that was going on all month. You can find an event page for that and the recordings of those past events. And today is technically the last event in November, but we're cheating a little bit. We have one next week with Andres Russo, who's going to talk to us about the boiling river in Peru. He had to move his due to some travel. So we'll have one more Can You Dig It event. We'll sneak it into next month. So today, I'm really excited for today's live event. We are going to spend a little time with Beverly Goodman. Last time I hung out with Beverly was at the Explorers Club in New York, last World Ocean Week. And we talked about a little bit of a different topic. We talked about how you can date things using really cool, I'm going to mess the name up again. She'll have to fix it for me, but how we can date things using, I'm not even going to try it. We'll just let Beverly do it when she comes in. From Earthfur, I think was what it was. But anyways, we're going to talk about something completely different today. We're going to talk a little bit about earthquakes and eruptions, and maybe a little bit about maritime archaeology. But Beverly, she blends archaeology, geology, and anthropology to explore the complex ways nature and humans interact on coastlines. So her work concentrates on the causes and effects of ancient environmental events like tsunamis and floods in an attempt to better understand what risks are present today and how broader climate-linked trends such as sea level change and fluctuation in rain and can be recognized in our sedimentary record. So I'm going to bring Beverly in. Beverly, foraminifera?
Yes, you just said it right.
I couldn't picture the spelling in my head, so I just took a stab at it. Nailed it. So that's what we talked about last time. So we're going to talk about a little bit of a different topic this time, but it's great to have you joining us live today. I know it's evening for you in Israel, but it's so great to have you with us. It's great to see you.
It's fantastic to be here. And for those who are celebrating, happy Thanksgiving.
That's right. Us up here in Canada, we had ours a month ago, but I know our American friends are definitely probably enjoying some turkey today and maybe some shopping tomorrow.
Yeah. So I'm very excited to be back again and talking about something kind of related, a little different, and hopefully talking about some real, somewhat current events, some events that have happened just this February that I had the good or bad fortune to experience.
All right. Well, we will turn classrooms loose with questions in a bit, but for now, I'm going to put up your screen share. I'll let you take over for a little bit.
Excellent. All right. Is everything showing okay?
Yeah, it looks good. And your camera is coming through nice and clear. So in our test, that wasn't cooperating, but everything's coming up aces for us right now.
Perfect. So I wanted to talk a little bit about earthquakes and, to kind of ask the question, I don't know how many people live somewhere where they've experienced an earthquake. I'm sure you've seen it on television or seen videos of it or heard about it. And it might even sound a bit scary, the idea of an earthquake, because of course it can be something that can be very, very frightening and something that can cause a lot of damage. But there's actually a lot of earthquakes that happen all the time, and that you can feel that don't cause so much damage. And when I was when I was very young, I sometimes we talk about like when did we get interested in our subject? And I actually had at my I'm giving away my age here, but at my 5th birthday party, we had a few friends over, and literally while we were playing musical chairs, all of a sudden the chairs started to shake just for a very, very, very short time. And believe it or not, this wasn't in California, this wasn't in Alaska, this wasn't in Japan. This was actually sort of in the middle of the United States, Middle East, the eastern part in outside of Cincinnati, Ohio. And I think that was such a shocking thing for me and such a surprise. And of course, it happened and everything was fine. But it definitely got me curious about, how does this happen? What is this all about? So I don't know how many of you have learned about earthquakes, but basically the reason that there are earthquakes is because the planet is not like one smooth skin. It's more like puzzle pieces that are sort of on the crust of the earth, and that they move relative to one another. And of course, when you have this movement, sometimes that's going to cause these releases of energy that we feel as earthquakes. And if we think about places where it's more common to have earthquakes, it may seem surprising, but there are some hot spots sort of and this is where more in the center of the country. But we usually think about California and we think about Alaska. And if anyone's here from Mexico or anywhere along the West Coast, these are places that have that experience it. And the reason is because these puzzle pieces, when they're moving, they are either moving away from each other. And when they're away from each other, like we see many times in the middle of the oceans, they're kind of creating they're building up new plates and they're moving apart. We call that divergent. And then you have what is called when they go towards each other. And when they go towards each other, you have a few choices, right? You can either go towards each other and then somebody wins, one side wins and the other goes underneath. Okay, so here you can see the subduction. Or you can have where one side goes under and the other one gets pushed up, or where even both sides are sort of pushing up against each other. And that's where we get the large mountain chains and areas where we see the Rocky Mountains or the Andes. These are places where what's happened is that these plates have actually come together and risen up because of that motion against each other. Now, a lot of you might be curious about where you can go and look. And the United States Geological Survey is kind of what we call the mothership. They have all kinds of information about earthquakes that are happening at any given time. So if you're curious, you can go into their website and you can actually look, and you can go just like Google Earth, go to different parts on the planet, and you can see what's happened in the recent few days or weeks, and see these tiny little earthquakes that are not the big damaging ones, and you can see how much activity is happening at any time. There's also a really, really neat application that I suggest taking a look at, particularly if you do live somewhere where you have earthquakes sometimes, and that's called My Earthquake Alerts. And this is an application that if you are if you happen to be somewhere where earthquakes are happening, it'll tell you where it was or how large it was. And it has this neat little citizen science feature that's called DYFI. Did you feel it? And this means that if you feel it, you go into the application and you enter in that you felt it, and then it will ask you, okay, what was it like? Did your chair shake, like I told you about from the birthday party? Or what exactly did you experience? And scientists can actually use that information to help get an idea of hazard risk, and when you have a certain size of earthquake, how it's going to impact people. So you're really contributing to something that can be helpful for planning and for management later. This is an old Hollywood character called Calamity Jane. And I put her up because when I was young and interested in things like earthquakes and other disasters, my grandparents used to call me Calamity Jane. And sometimes I think that this was a really, really good nickname because it seems to sort of, I hate to say trouble follows me, but I definitely have experienced quite a few of these natural events without intending to. So I'm going to tell you about this recent experience that I had. That I'm a marine geoarchaeologist. I forgot to really say that in the beginning. So the work that I'm doing is I'm looking at geology and I'm looking at the archaeological side. And many times I'm working underwater. I'm looking at how coastlines change. And so one of the places that is very interesting to me is Santorini. This is an island that's a volcano. Okay, so in the background here, you can see some of the students that joined on this course. What we see in the background, the middle, this is actually an active volcano called Kameni. And then to the sides, this is the round part all around the caldera of this ancient volcano. Now, we were going there to learn about the archaeology and to visit these very famous sites. And the sites, they're famous because this volcano erupted about 3,500 years ago, and it covered the tops of the entire exposed part of this volcano have an incredible amount of ash. We were talking about in some areas up to 40, 50 meters. That's like a 15-story building thick of this volcanic ash. So it's an incredible place to go and learn about geology and also learn about archaeology. You may have heard of Pompeii. So this is sort of a similar situation, like you may have learned about Pompeii. So I was going there to be part of a field course, and I was invited by a Greek colleague of mine. And as we were about to get to the day of the flight, there were suddenly a lot of earthquakes, and the news was talking about earthquakes in Santorini. I'll share with you a funny little WhatsApp chat that we had where February 1st, right before we're about to get on a plane to fly to Santorini the day before, and I wrote her and said, okay, is everything okay? Do we need to worry? Can we come for the course? Is it going to be okay? And her response was, we will be shaking. So if that doesn't tell you that scientists are built a little bit different, we definitely are, because while other people are trying to avoid going there, we're looking forward to seeing this. Now, I didn't feel very scared because Evie, who is my colleague, she is a volcanologist. And so if anybody knows whether it's safe or not, I rely on her. So I was feeling pretty confident. But to give you an idea, this is a plot. Here we have Santorini is down on this green on the left bottom here. That's the island of Santorini. And all of these little dots are earthquakes. And you can see that what they do is the bigger they are, the larger the size of the earthquake. And when we get into the stars, that means that it's 4.5 or 5 magnitude. And according to the color is how deep the earthquake is, okay, how deep beneath the Earth's surface it's happening. And so by having this information, the volcanologists, the seismologists, the geologists were able to kind of track what direction are the earthquakes moving and trying to figure out, do we have plates that are going underneath each other? Is this related to the volcano? Because you can also get movement related to the magma moving around beneath the volcanic system. And so we really had this opportunity to be in Santorini as this was happening and to feel these earthquakes. So if you can imagine, the earthquakes were happening all the time. So I had felt in my entire life, my entire career as a geologist, I can name about 4 earthquakes that I actually felt. I told you about one of them, and there were a couple of other ones where I was able to feel the earthquake. And all of a sudden, I'm in a place where we're having earthquakes all the time. So we have an earthquake. Many of the earthquakes you can't even feel. Okay, so if it's under 3, even if you're moving around, you might not even feel it when it's around 4. And then as it gets above 4, you start to be more aware of it. And so we were having, it's sometimes 2 or 3 in an hour. That would be big enough that we would feel it. Definitely if we were sitting still, we'd feel it. And some of the bigger ones, even if you were walking around, you could feel the shaking happening. Now, the island itself, most people that could evacuated. Okay, this is a photograph from the main port leaving Santorini. So as we're coming, these are people who decided to leave on the ferry. They left for many reasons. Obviously, it's not very, it can make you very anxious to have this motion happening, even if people tell you that they don't expect it to get worse. But we did decide, because we had all of these scientists there and we took certain precautions, but I won't, we can never be fully 100%, but the volcanologists were noticing that these earthquakes were sort of traveling along a certain direction. And so it seemed like it was more related to some movement of magma and not related to something that would lead to a very large earthquake that we had to worry about our own safety. Now, so the island more or less emptied. And the people that stayed behind we had some medical personnel. Here we have the fishermen. And so we went around and we spoke to people and we asked questions. What did they observe? Did the fishermen notice anything different with the fish? And sure enough, they did. They noticed that they were seeing different species than they usually saw. Nothing too dramatic, but they definitely were seeing that there were some patterns that were sort of changing because of this seismic activity. Because you have to remember that if there's seismic activity under a volcano, it might change the water chemistry a little bit. Just the vibrations and the animals are going to sense this, sometimes even more so than there's good as any of the instruments that we have. And we would be sitting there and have our computers open, this picture on the right, and we would feel the earthquake and be able to look at it at the same time in the reports from USGS and from here you can see I'm looking at earthquake.usgs.gov, and it was a very, very for scientists and for the students, it was a little frightening, but also a very exciting experience. Once in a lifetime for sure. Here we have one of the faculty is lecturing. Here's some of the students, and in the middle of lecturing about geology and about earthquakes, we would have earthquake warnings. Now you're going to see actually how calm the students are. I hope this video will play nicely. Let's see here. Here we go. Okay, so you hear that noise? So the students now are pulling their phones out to take a look at the alarm. See how big it was, but you'll see they didn't even move. So we got very accustomed to this happening on a regular basis, as you can see. So what we did is we actually went out. This is a picture on one of the ships going into the caldera of the volcano. And there was a team that came from Germany and from Norway, and we had instrumentation that they put down into the volcano, into the depths, in order to collect some of that data about the temperature, about the chemistry, to see whether there were any changes related to the seismic activity, related to these earthquakes. So here we are with Evie heading out into the caldera, into the center of the volcano. And eventually, this is a paper that the scientists published just about a month ago, that's summarizing what they saw and how they were able to track these earthquakes moving across this line, and they concluded that in fact this really was the creation of what we call a dike. And a dike is, if you're ever out hiking in a place that has nice geological features, you'll see the layering of the geology, and then all of a sudden you might see this sort of this bar of a different type of rock that cuts through everything. And that's what was happening, or what they think was happening, was that it was like opening up these cracks through these other layers, and the lava, the magma moving through it. Now, it did end up quieting, okay, after a couple of weeks, which also reinforced what they thought it was, that makes sense, that it wasn't two plates that were going one over the other, but in fact it was related to the volcanic activity that was happening. Now, the people that were there, of course, I mean, were very concerned, and this was why we were interested in looking at what was going on, because is the volcano active? Okay, now we know Santorini is an active volcanic system, but the question was, is it active to a point that we could have a real eruption? And so this was one of the questions. And the other thing that was on my mind, and definitely on the mind of the students, because this was part of what we were learning about while we were there, was the issue of the Bronze Age eruption. So that's an eruption that happened over 3,000 years ago that left that large deposit of ash that I told you about. And so as we were there and seeing people leave the island and some people staying on the island, it was definitely one of the things that we were thinking about. We were thinking about how in the archaeological site, the good news in the archaeological site of Akrotiri, which is from that time, is that we don't see any victims there. It's not like Pompeii. If you've heard about Pompeii, in Pompeii, they actually found that there were many people who sadly that died, that were victims from the volcanic eruption, that were caught there. And that is something that we don't see from this Bronze Age eruption. And that experience that we had being on the island, where we had days of activity, of earthquake activity, kind of gave us a sense of when the fact that perhaps, we hope, most of the people that lived there at that time managed to escape. They managed to leave. So it was really a phenomenal experience. We had the advantage of the instruments and the measurements, and we get to be a lot smarter and to know the risk factor, but they wouldn't have known that. And there's a good chance that many of them were saved because they decided that they got the hint that maybe it was time to go. Now, there were also people that lived through a very big earthquake in 1956. There was a big earthquake, and it also had a tsunami that was produced from it. And so this was one of the things that a lot of the local media and people were talking about, and a lot of questions over whether we needed to be concerned that was going to happen again, because Santorini and some of the other islands had a very, 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 had a lot of damage in that earthquake. And there's still people alive today who remember it and who experienced it. And of course, people who heard the stories about it. So now, as the media was sharing all of this, there were also in other parts of the Mediterranean. So in Israel, they started to talk about, do we need to prepare for a tsunami? And I wrote here, this is good news. And yes, I'm going to tell you, as a marine geoarchaeologist, that this is really good news. Why do I think it's good news? Well, here I am, okay, in a day in the field working underwater. And one of the things that we do in the archaeological excavations underwater and in the collections that we do is we are looking at layers underwater. And off of the coast of Israel, we were able to recognize layers of destruction that we recognize as being related to ancient tsunami events. Now, why am I telling you that this is good news? Well, it's good news because the archaeology is giving us information that not only is it helping us to learn about the experience of people in ancient times, but it's also giving us really, really useful information so that we can live better, so that we can be safer, so that we can be ready and know that there's risk, and to be prepared if it happens. So this, for example, is one of the first tsunami deposits that we found. You might be thinking, shell, really? That's a tsunami deposit? But what I can tell you is that these are species of shell that were transported nearly 3 miles away from where they actually lived. So that this is how we knew that they weren't in their natural position, that something very powerful wave had to move them. That was one of the first pieces of evidence that we had, and we've had many more since then. Now, this is an image from Santorini where we've just begun, and if you're, we'll probably put a little plug in here for a special coming out in National Geographic, probably in February or March. It should be coming out, talking about this research that we've been doing in Santorini. But we're starting to find these sort of layers offshore that might be related to the eruption of Santorini and the tsunamis that were created from that eruption. So back to why it's good news. The reason that it's good news is because, like I said, by having these concerns and that people are aware of it, basically it's a way that we're able to save lives. So this is why I consider it a very, very good thing that we're able to learn more about it, to prepare to know how to respond, and that people are able to react and be safe. So that's what I wanted to share with you.
I took myself away. There we go. Excellent, Beverly. That's really exciting that you got that opportunity, kind of right place, right time to observe, a really interesting phenomenon that, you're right, a lot of people would feel very differently. If that started happening under their feet, they'd probably look like that crowd who was waiting, I guess, to get on their ferries and get out of the scene. Well, I do have some questions here for you coming in via the chat, so don't be shy if you're tuning in to put a couple questions in the chat. The first one I have, you mentioned the plates moving, and normally you think of earthquakes happening along a fault. In this case, it was movement of lava. So this question is a more specific about, what is it about the movement? Is it the amount of lava? Is it the consistency? Like what about it moving?
Yeah.
So
these things aren't, tectonics and volcanic seismics aren't completely separated, of course. A volcanic system is related to these plates, and Santorini is similar in many ways. That whole system is very similar to the Galapagos Islands that you may have heard of before, and so it's a complex where you have sort of smaller plates and weaker areas and exposure of the magma. So the seismics that you get from the volcanic seismics, it's exactly that. You get a buildup. You can get a buildup of the magma, and then it's sort of finding the pressure is building, or the volume has increased for whatever reason, and that could be also movement in other parts, relate to the movement in other parts of the system. And then it's basically going to search for the weakest area. So it's going to expand, because when things heat up, they expand. And so the earthquakes that you're feeling, it's almost like kind of like opening a zipper in a way. It's the earthquakes were occurring in areas that sort of had in a sequence that you could see that as the pressure was building in a certain direction. Because remember, I said they can know the depth.
Yeah.
So that was the other thing that was important, is watching it go. Is it coming up to the surface? Is it going? Is it moving? And it was kind of like a nice slope, so that there was a sense of calm in the sense that it's not erupting up to it's not getting to the surface, that it was moving along sort of a seam between layers. Yeah. So the answer is yes, it does relate to the volume. Of course, the volume can change with heat and as it goes up and the pressure goes down a bit, it's going to be able to expand a bit more. But yeah, and it calmed down because at some point in this case, the volume that was moving, it exhausted itself. It didn't have the pressure slowed down or the volume no longer increased, and then it resolved. The same thing happened about 13, 14 years ago. I think it was in 2010, 2011. They had a similar sequence. And so I think that's the other reason why the geologists were fairly calm, because they recognized a similar set of events.
Yeah. Okay. Okay. Another question here. What was the largest earthquake you felt while you were there? And then what was your plan if there was a larger one, something more serious?
Oh, good questions. So the largest one that we felt when we were there, I think, was 5.1. And if I could just throw a little aside in there, which was kind of interesting. I noticed at one point that if anyone spent time on a boat, okay, and you get that sort of movement feeling when you're on something in motion, it's a very similar sensation. I really felt like I spent that week on a boat. And when an earthquake would happen, I actually could feel it in my ear. Like I would feel like I like that little sense of like losing your balance a little bit, that little vertigo feeling. I might not see anything or I might not feel the shaking, but my ear would tell me. So that's just kind of an interesting thing I learned while I was there. And I know that my ears are able to, basically from 3.7 up, my ear feels it. So this is something. And we had an earthquake 2 weeks ago. There was an earthquake that we felt here, and I did feel it. I came out from a dive and I had that sensation. I said, oh, that's funny. I feel like I kind of, and then about an hour later, someone said, did you know there was an earthquake an hour ago? And it was picked up on the sensors here. And I laughed. I said, well, I felt it in my sensor. Yeah. So that was the first part of the question. And the other question was, what was our plan if there were to be a serious earthquake? So because Santorini has a history of earthquakes, the buildings are like in most places, you do have very strict standards for how the buildings are constructed so that the buildings should be able to withstand a major earthquake. But on top of that, they actually have, you can exit the buildings there. When you go there, it's a little bit strange to me because you're like, wow, how come I have so many options on how to leave this room? A stairway goes that way, a stairway goes that way. There's sort of endless options for getting outside. And that's part of their building code, is that essentially you can get out. The buildings are built so that you never have a long distance between a room and the outside. And in an earthquake situation, that's definitely where you want to be. You want to get outside. So when we did feel an earthquake, the general rule was that if it lasted for longer than a certain number of seconds, we would go outside. And it rarely did. It was, I don't remember exactly, but I think it was like, if it lasts longer than 15 seconds or 10, I think it was around 15 seconds, then we should go outside. And I think we only went outside once or twice the entire time we were there.
Yeah. Well, this next question is, I like this one. So you and your colleagues were fairly confident based on what was happening that, you were safe. Is there some sign that, or something you would have felt to say, you know what, this might be an eruption? Is there something that scientists were looking for?
I think they were, well, I know one of the things was looking at the depth of the depth and the direction, because they know which of the volcanic areas have been active recently. So like I mentioned, there's the active volcano of Nea Kameni, and then there's another volcano called Colombo. And Colombo is the one, it's underwater. It's a submerged volcano. And so that was really the major point of interest for the geologists, was to really watch and see, is it headed towards Colombo? That was the only place that was, and that is not Santorini. It's nearby, and so maybe that's the other reason that we were, maybe naively confident, but that was a bigger concern because as you saw from the maps, the earthquakes they occurred in Santorini, but they're basically on a line from Santorini up towards this other volcano. So that was the big worry: is this movement going to connect into the system of Colombo? Because that would have been the highest likelihood of an eruption.
Okay. Beverly, I have a couple marine questions to wrap us up. This is from a 4th grade class in Toronto, and they want to know, how do you know where to start looking for something underwater? So I think they're thinking like a building or a
yeah. Wow, that's such a good question. Okay, first of all, one of the biggest problems in ocean sciences at all is that we know more about the moon surface than we know about the bottom of the ocean. This is always used as the example. So we have to do a lot of work beforehand. Both, if we're looking for something archaeological, we do mapping, geophysics mapping. So we'll try to do surveys where we have kind of like if you can imagine like sound waves, where we can actually look underneath the sea bottom and see where, and try to, before we invest all the time and energy in going and excavating, which we can only work on this a tiny little piece, and so literally that needle in a haystack problem. So what we try to do is we try to change the size of the haystack. So how do we change the size of the haystack to find that needle? We do broad surveys using geophysics, looking underneath the sea bottom. It's sort of like not an X-ray, but using techniques of remote sensing, where we're able to look underneath the surface and see if we've got objects or walls or anomalies, things that shouldn't be there. And then once we kind of reduce our haystack, then we start to kind of play battleship a little bit. Okay, let's try in this corner. We'll do this corner, this corner, this corner, and try to maximize our chances of reaching what it is that we're looking for.
All right. And the last question here is, do you ever get frustrated by the amount of time you can stay underwater? Is there anything you can do to extend it?
Yes, I very much so. And what we do is we're always looking for new technology, and we've solved that problem. We've taken on. We're using technology that solves that, such as we'll work with what are called rebreathers. And so rebreathers, when you're normally doing a scuba diving, you have your tank, okay, which has your air in it, and once the air is gone, you're done, right? You can't, that limits you. But with a rebreather, because it actually recirculates that air, so instead of having 45 minutes, you might be able to have 5 hours. And so actually 8 hours, it depends on your system. And so then we become limited by being hot or cold and being hungry. So we do work with rebreathers so that we're able to go, and we're able to go to the office, get to the thing that we're working on, and just stay there for a few hours. So yeah, we're always looking for ways to stay down longer.
All right. Well, Beverly, I want to start out with a shout out to our Canadian crew joining us today, as well as to our American classrooms, who will hopefully catch, some of them will catch the recording next week after their Thanksgiving. Beverly, thank you so much for giving us some of your time today. I know it's later in the evening for you, so I really appreciate you joining us. And talking about the earthquakes, but also shedding a little light on marine archaeology, because we haven't touched on that yet this month.
Absolutely. Invite me back, and I can talk only about marine archaeology next time.
I think we might just have to do that. As a diver myself, I'm a little biased to the underwater action.
Absolutely.
All right. Thank you so much, Beverly. Thank you so much, classrooms. Enjoy the rest of your week. We're going to sign off for now. Thanks, everyone.
Bye.